Here in part 2, we're going to look at some applications of this half-life thing. We're going to start with radiocarbon dating. Radiocarbon dating is used to determine how long ago something that was once living was alive. And that's because it works because we ingest carbon through various means, through the food chain, through exchange with the atmosphere, and plants, animals, everything undergoes this. And as long as we're alive and we continue to exchange carbon with the environment, then the amount of carbon in us, it stays constant. Now, carbon-14 is radioactive. Normal carbon is 12. So there is a fixed amount of carbon-14 in the environment, so as long as we interact with the environment, that stuff stays in us. Once we die, or once a plant dies or an animal dies, it no longer interacts with the environment, and the amount of carbon in it then is fixed, and it begins to decay because carbon-14 is radioactive. All right, so I got a little problem here, and I'm not going to work it out, so we're just going to talk through it together. The half-life of carbon-14 is 5,730 years. All right, so let's say we go and we find a site where an ancient civilization lived, and here's an axe, and so we look at this axe handle, which came from a tree. You know, this does not work for the metal, it only works for things that were once living. So this came from a tree, and let's say it has 25% as much carbon-14 as a living tree does. All right, so if we think this through, after one half-life of 5,730 years, there would be 50% as much. That's what half-life means. And then after another half-life of 5,730 years, there would be half of half, which is 25%. So in other words, it would take 2 half-lives to get to 25%, to get to this 25%. And 2 half-lives of 5,730 years is approximately, and I didn't do the math, 11,000 years, a little more than 11,000 years. So this axe handle came from a civilization that's 11,000 years old. And that's how they can determine how old various things are, because back then pretty much everything was made from living things. Even cloth came from cotton or linen, and so they can age those garments even because they came from one-time living things. All right, and there's some other things that radio isotopes will work for. Diamonds can be determined, the age of diamonds can be determined by how much radioactive material is in them. Uranium-238's half-life is 4.5 billion years, and so these diamonds have been around for millions and billions of years, so they can determine how old they are by how much radioactive uranium-238 is in them. And some other uses in the medical field are as radio tracers, because then you can put in mildly radioactive substances and they will travel to parts of the body where those things are being used. For example, carbon-14, because most of our food is composed of carbon, you can follow that through nutrients into the digestive system, in the stomach and the intestines, and then travel on through the whole digestive system, follow a nutrient as it moves into other parts of the body. Iodine-131 is used to trace the thyroid because the iodine is taken up in the thyroid. They also can use radioactive iodine in the thyroid to treat certain disorders in there. They can use thallium-201 or technetium-99 to assess heart damage. And so in the book also, if you look on page 681, table 19.4 has lots of other uses for radioactive isotopes. This is an image showing how different isotopes are taken up in different parts of the body for smokers versus non-smokers, and you can see how it lights up the brain and lights up the kidneys because these things are being taken to those places. All right, so there's a variety of things we can use radioactive isotopes for, from determining how old cloth is to determining or treating even different maladies in your body.